as said, we have 4 parts: general, QGIS, QGIS, and Rhino. I have explained a bit about what we're going to do in the parts, and I think it's time for Erik to start.
Well, let's first see if there are some problems that people have encountered. As we set up this course this way with the videos, we expected you to get into trouble after trying stuff out. So I'd say let's first give you the floor a bit as a group or as person. So anything that went wrong, anything that you want to know more about, things that you've encountered, data that you could or could not find. You can switch on your mic or you can put them in a chat. Both are okay. This is always the hard part. Do I ask my question as the first question or do I not do that? That's always a big question for all of you. And you're entitled to do so. And if not, we just go ahead with some things that we think might interest you, but well, you're master students, so you can choose your own course now.
Okay, Erik, I think there are no direct questions at the moment. Maybe questions will pop up later. Please put them in the chat or wave your hand to inform us that you have questions.
Yep.
Maybe it's good to start with a couple of things we would like to explain, elaborate on.
Yeah, let's elaborate a bit more on the 3D Bach data. And let's have a look at that and see if we can start a discussion on that. I'll share my screen with you. Okay. See, let's check this again. Let's see if Zoom is all. I can see if someone tries to raise a hand. All right, we have here the 3D Bach. Sorry for the mix of Dutch and English terms, of course, in this situation. This is a site where you can view, download, or research the 3D buildings in the Netherlands. And it's kind of a strange website, but let's have a look at this, because you've probably seen it in the video or you've tried it yourself to work with it. And there's a few things that might need a little extra explanation. Depending on the way that you research stuff, some people are trying first, see if you can download it, view it, and if it works, it's fine. Some people start with the documentation. That is very much dependent on how you do stuff in general. In this case, whatever your method of studying is, I would suggest you have a look at the documentation as well, because it really tells you about how this data came to be. If you look at the outlines, the contours of all the buildings, are surveyed, and they're all done by municipalities. So the footprint of every building it's pretty accurate. I would say every corner of every footprint is within a maximum range of 30 centimeters, but most of them are within 5 centimeters of the truth on a national scale. So we have about what could it be, 10 million, 11 million buildings surveyed very accurately. What we did at the TU Delft is that we combined the topography, the footprints of the buildings with height information. And the height information is done through laser scanning, aerial laser scanning. And there's a lot of points measured on every roof of every building. And that is basically how it works, that you combine these points and you find your value for the height of the building. But there's not one value, because you have, on average, you have, I think, about 5 or 10 points for every square meter, something like that, if I remember correctly. So you have quite a few points on every roof. That means that you could add one value to it, or add something else to it. But what the research group did was that they work in percentiles for ground points and for roof points. So, and I think the best example is here. This is, for example, here you see all the points scattered on the roof. So, for example, houses, you see the same scatter every time, and depending on the percentile of the roof points, a value is given. So the 99th percentile is more or less the highest point on the building from all the roof points. But for example, you could find a chimney on a percentile 99 instead of an actual roof. 99, so probably an antenna will filter out, that it will probably be the 100th, but a chimney is very well possible to be the 99th percentile. Below 25, it's a bit of a hit and miss situation, because you could have too many points that are classified as on the roof but are actually on the ground. So somewhere between 25 and 99, there's the true value that you're looking for. And it depends very much on what you want to see if you could actually use that. Now, this is for if you want one value for the height of the building. And Stefan is I think, knows a bit about the 3D modeling more than I do. So I'm talking a bit while he's eating, but I hope he's finished his soon. But there are different levels of detail in 3D modeling, and if you have one value for one footprint, as you can see in the image here, that is LOD1, or level of detail 1. The research group, the 3D research group, is going for LOD2 or 3 now. They have the roof shapes as well now, but as we're doing this here, we're most on LOD1, aren't we, Stefan?
Yeah, maybe it's good to jump in here. So all the data you get, you will start with LOD0. You will only have the footprint of the building. And that's important to know, it's the footprint of the building. So if you look at the example of the campus TU Delft, you will see that the library will have the footprint. And if you make the 3D model out of it, you extrude it, you'll get a shape like shown here on the screen of Erik, LOD1. So it's this roof, this grass roof is not going up, it's just a box. And there's no more than that. It's just the ground shape which is extruded to a certain level depending on the percentile you've chosen. Yeah. And to make it LOD2, you need to do more. We have to do it manually, so you have to know the kind of roof there is, and you have to know then what the height is of the how to say the
top and
the facade and the top, and then you have to make it yourself. The GIS, the 3D GIS, the 3D geoinformation group tries to do that automatically. So they try to estimate the kind of roof, and based on that, they also try to make the modeling automatic. Although if you look at the viewer is no more than LOD1 at the moment. Well, to go from that to LOD2 is one step further, and that means you have to add a lot of detail manually. Yeah, please, Erik.
No, go ahead. I'll look up the new viewer as well. But in the meantime, but this is an interesting building. I don't know if you recognize this building. Here's the St. Sebastiansbrug. They're going into the center, and then there's this one huge building here, which includes quite a bit of the Bastiaansplein, which is a square here. There's shops around it. There's the Jumbo, the supermarket here and everything. But the building looks quite a bit larger than it is on the outside. If you just walk there, any idea how that could happen?
They took the footprint of the parking garage underneath or so?
Yeah, exactly. Yeah. By definition, in our the Bach is one of the key registries, and in this key registry, the largest size of the building, no matter on what floor it is, underground or ground, is the footprint. So you have some strange buildings here as well, because this building is built over some buildings here. So here's something strange going on as well, probably. There's that gives some extra issues. So if you're looking for the footprint on the floor, the on ground level, it's better to use a different. It's better to use the topography base map, the large scale topography base map, the BGT in Dutch. But this one is interesting.
Can you will show later on the difference between the BGT and the Bach for these buildings?
Yep. We'll show that later on. I'll have to check for a bit because there's a new viewer. The research group, the 3D research group here at the faculty has done some real nice work on that, and I'll show you that as well. I'll give you the link because it's really interesting. But my Zoom is taking over my it's taking over my screen, and I have to. I'll switch you to this screen then. Makes it easier. Where's that one? It's a really nice one. In 3D info, I'm looking for the Bach node viewer. Yeah, that's one. Here we go. This is the new viewer.
Version 2.
Yeah, the version 2. And as you can see here, we have a much better view of the building. This is not exactly LOD1 anymore.
No, it's not at all. It's
LOD3.
Oh, it's LED, yeah. At least LED2 with the roofs and
and there's some extras here as well.
Yeah.
LOD2.5, I'd say. There's no 2.5, is there? No.
Oh, you can always make 2.5.
But it's 2 plus.
Depends on your definition, but
yeah. So this I'll share this in the chat so that you can have the new one as well.
Because the old one is in LOD1 for sure, and I think I was using the old one because when I downloaded the data, also with the tiles, I selected the data from the tiles, then I was using the LOD1 view.
Yeah, it is. Yeah, I know this just has one major value for every building. So let's check one of these buildings and let's see how it would work in practice. If I just pick one, doesn't matter which one. You can see here it's got an identifier, etc. Those everything that should be in the Bach registration. It's a building from 1982, and as you can see here, there's ground level height, and well, it's pretty regular. Most of them are around 36 centimeters above NAP, and the roof values here you can see there's a roof 0.25 of 11.4 meters, and that is slowly going up. This is from 1140 something to 1165 I would say this is a flat roof. I figure that these buildings have more difference between the roof. Oh yeah, I can see there's a parameter as well for roof flat or roof. And this one is false, so it's not a flat roof. So you can see the highest point here is around 8 meters, and the lowest roof measurement is 3 meters. I would say this is a there's some difference here. Okay, right. So that's about these values and how to use them. There's another thing. It's the filtering of the Bach data, and they already did quite a bit of filtering on this. And I'm going to show you the filtering using the BGT, because all the Bach data that we use from here is already filtered. But as you can see, and I'm not sure if everyone understands the Dutch that is being used here, but this field name, that means that is the start of the validity of this data set or this data object. And this is the end of the validity. So that means that if there is any end date in this field, that means that this status is already invalid because it ended. So if you use the filter that one should be empty, is null, in that case, you only get the valid objects. Now you could ask yourself, how important is it to keep all the records of all the things that are no longer valid? Because why not just remove them from the data set? And well, that is because sometimes you need to go back in history a bit, especially if you talk about building permits. It might be interesting to see how the building came to be. For example, one of the things that you can change for every object is the status of the building. And there's a few statuses, and the first one is this one, permit granted. So that means that you're allowed to start building. But permit granted means that already the building exists in the registration. So it is not even there yet, but well, permit granted. So it is already in the registration. And the next phase is building started. That means that, you know, that the company that started working on it has made a notification that we started building on it. Then you get, it is done. What's that status again? Pand gereed? I'm not sure. Pand in gebruik, in use, building in use. And that could be building in use, but we didn't survey it yet. Or it is building in use, and that means that it's all, that geometry is correct as well. Then the next one is you can get a permit if you wanted to demolish it. So there's another status. Then it's demolished, and you could also have, we didn't build this one. So we got the permit and it came up in the registration, but we didn't build it. So those are all the statuses that buildings in this registry could get. So you can see that one building, from the moment it's being designed to, well, it's kind of a cradle to cradle registration. We want to know everything about all the buildings. So if you in GIS, what your problem could be that you're tearing down, you're building up your data set, and you're doing your project with that, and you've got way too many, for example, in this case, buildings. So you have to filter everything out. And I'm going to do the filtering in the second part of this training session today. But this is the background of it. Our registrations are done in such a way that we want to have everything in there. That means that you have a lot of statuses that are no longer valid.
Erik, one addition to that. If the building is there and it is measured in, but there's no AHN value, then there's also a way to filter them out. And that's what I've shown in one of the tutorials.
Yes.
Because this can be up to date, but imagine that that area, for example, indeed, they have been built between 2018 and 2020, but there is no height information for these buildings.
Nope.
So outdated height indeed. So the AHN we are using to estimate the height, the different height values, is not accurate. It's not there yet because that's from 2013.
Yeah.
And you have to think about what to do with these buildings. Oh yeah, and there's a nice one as well next to the new media center, the teaching lab. Up a bit up next to IDE. Yes, that one, for example. So also in the TU Delft area, you get real mistakes if you only look at this data. So you really have to think what to do. So I excluded them, but in principle, if you want to do the campus project, you should include them and manually extrude them to the right height.
Yep.
Would be my suggestion.
Yeah, I would suggest that too, because if you're doing a project on a certain area and you present your results and the first thing that people are looking at is, hey, why is this building missing? Come on, it's been there for 5 years already. Why do you work, you do such nice research and you work with outdated data? That's ridiculous. And you're pointing your audience to exactly the things that you're not wanting them to look at, because you want to bring a message across, and this is the wrong message. Because the message that they will remember is that, yeah, it could have been nice if you just worked with actual data. And that is not the thing you want to people to remember you by. In this case, the way that we do the height information with the AHN, actueel hoogtebestand Nederland, for those who want to know, the AHN data it's done every 5-6 years, more or less. It's quite a process because you have to fly all over the Netherlands, do very exact measurements from laser altimetry, and they want to have it. It is not very difficult to do as such because we know how to do it, but to get it right, to get it up to the centimeter right for the whole of the country, that is quite an operation. So they do that only once every 5 years or so. Again, just like all the other data sets that we're using, every data set is developed for a specific purpose. This AHN is developed for a specific purpose, and you can see the purpose if you see the organizations that are working on it, which are the Dutch water boards, de waterschappen, and Rijkswaterstaat. So if you see that those two types of organizations work on this project, it is probably has to do with water and safety, because those are the issues that they have this kind of data set for. So there's no need in doing that every 5 months or so. Every 5 years is enough, because they work on long-term perspectives anyway. That means that, well, we can use it, but we're not the primary client for them. So there's always the question, why don't you update this more frequently? Well, because it's bloody expensive and we don't need it. If you want it, you can do it yourself. That's the answer you normally get.
Well, that's an important one. So the automatic extrusion in Rhino, it's beautiful, but you're missing a lot of buildings and you're missing the right forms in certain cases. And that means you have to manually intervene there. The question is if you need a model like this, the LOD2 or more, or that it's enough to have LOD1 model. But even in the LOD1 model, the library, the aula, they are not correctly there. And probably you have seen more buildings. Yeah.
Here they are.
Yeah.
This one's beautiful.
That one, it's a nice example.
but again, here you see these buildings are missing.
Yeah.
And that is because the AHN in Delft is from, I think it was 2014, but I'm not sure about that. So you're missing quite a bit here.
Yeah.
You have to do that manually and correct everything.
Yeah. Another interesting building which is missing, or which is not correctly drawn, is the AV building. The AV building is the highest building of the university, and it has a low-rise and a high-rise part. But in the Bach, it's one element, it's one building, and there's no distinction between those two parts. And that means you have to manually adjust the form of this building. If you're, at least if you're working with the Mako Park, if that's part of your plan, and you have to do something with sun and wind for that area, then you have to adjust that building. Yeah.
Yeah, as you can see here, this one is correct in this way that this is the building, you know, and you see there's a lot of, well, there's the low-rise area around that here as well. In the model here, they did it correct. As you can see, there's the low area of that building, and here's the high-rise. But if you look at the this one, you see this is all one building. So if you want to do something with the AV building, if you want to model that, you can see there's, yeah, well, the roof 0.25 is at 8 meters, and the roof 0.95 is at 87 meters. There's a big gap here, and that is because this is just one building, and you can split this up perhaps into separate separate entities, separate objects. That is where your skills in Rhino and in editing and come in nicely.
Yep.
There's always some manual labor involved. It's great if you can do 95% automatically, but even for 80% automatic, I would agree to that. 80% and 20% is manual labor, or at least adjustments. Okay. Any questions about the 3D Bach data?
Yeah, there's a question from Jona. Which data set did Google use, or did they also manually adjust AV?
The thing with Google is you never know what they use, because they don't disseminate their knowledge, or at least not really that much. So what I can say is that they use a lot of aerial imagery, and I think they made these models using photogrammetry. That means that you have different aerial pictures from different angles, and you make a 3D model out of that. And then you cannot go wrong if your photos are correctly positioned. I remember seeing first examples of that in kind of web applications with tourist photos of touristic buildings, for example, the Sphinx in Egypt. That there were so many people that made photos of that you could combine all these pictures and make a 3D model out of that without even going there or taking the pictures yourself. You could just collect these pictures and model that. And I think Google does something similar, that they use all the images that they have to make 3D models. I wouldn't know if because they don't send out airplanes with the laser altimetry or something with that. They just don't do that. They reuse stuff that people submit to them. So
yeah, I think indeed it's mainly photogrammetry. So if you have multiple photographs of the same building, you can estimate the points, the corner points of a building. Yeah. But they also use models. So a lot of people make models and they upload them. and they use those models to place them here and add the photograph images on top of that. But you see a huge improvement. I think the past 5 years.
Yeah.
I mean, before that it was really ugly. They had this building formed, the trees were in it, and you could hardly use it. So if you zoomed in, then it was so ugly. It looked like a strange building on the moon, you could say.
Yeah.
And today it's getting better and better. It's very detailed, very accurate, very quick as well. Not that slow anymore. But
No,
indeed,
this-
for the cities, you will see some kind of models. Yeah.
I'm not sure what they do, but this is ridiculous, of course. This is just a consumer application. It's not like professional stuff. And these apartment buildings, as you can see, they're leveled with pyramids, so that if you zoom in, at first you get a kind of a rough image, and then they come up with better imagery.
Yeah.
But
Unfortunately, we cannot use it because there's probably not a real geometry behind it. They're not sharing it as well.
Yeah.
Well, you could compare this with the 3D Rotterdam, and that one we can download.
They don't even mess up the boompjes anymore.
No.
Wow. The shapes are really good now.
Yeah. It really has improved.
It's been a while since I've been looking at this, so I'm amazed that they actually got it right now. Sorry, geo nerd here. So yeah, that's about it. And this was, I think, the 3D model in Google Maps was done, I think, about 5 years ago. They were the first experiments. And if you looked at Rotterdam at that time, I've made some screenshots of that, because from one point of view, it looked all right. But if you slowly moved around it, you saw that it was just from one point of view that they looked all right. So if you turn around that, you would see something like the buildings going that way. This was ridiculously bad. But they've learned so much just by doing that and continuously improving that. So it's really interesting. So yeah, just one question of you, Jana, sorry. And then we are elaborating like mad on that. Yeah, and the answer is, I really have no idea what they actually use. But I do it pretty well, I'd say.
Okay, maybe
time for
Erik, to close the last part, maybe it's nice to show 3D Rotterdam as well, to have an idea how also cities make their own 3D models, and you can download it.
This one, I guess. Yeah.
Yeah, that one. It's a bit slower.
Yeah, but this is based on actual data, so I'm not surprised that this is slower. And of course, Rotterdam does not have the computing power that Google has. But still, it works the same way. Oh, and I see they use the formal background. They use the same background map layer that you can find in QGIS as well as the BRT achtergrondkaart. And for the height model, they've been using for the on floor level, they've been using the DTM and not the DSM, as I can see here, because bridges, I'm not sure, I think there's a bridge here.
I hope so.
I would be surprised if there wasn't a bridge. But this is exactly what happens if you use the DTM. So you use it on ground level, and you define that a bridge is over ground level. So you ignore the bridge because the water is the ground level there. And then you see this kind of strange, and especially if you drape the map on the surface, you get this kind of strange. I would like to do the paint job here. Yeah.
Okay.
No, but this is as we say, this is not a bug. This is by design, because it is based on a very strong definition that we use a DTM for the surface, not the DSM, because otherwise you would also get all the trees. So if you use the DSM, a tree just along a road would mean that the road would be draped over the tree if the tree would be hanging over the road. So that would be weird as well, but weird in a different way. So yeah, you have to use DTM, and in that case, you drape the map on the DTM, and you get some kind of this as well. Yeah, this is typical of a simple complex, and the world is not simple. The world it's really multidimensional, and if you try to simplify that and using just okay, we have ground level as one dimension, and we have buildings on top of that as a second dimension, then it's not, well, you get this kind of result. But all in all, this is excellent, and you can download data from here as well. If I'm not mistaken, Stefan, I never did. I think you did.
Absolutely, yeah. You can download pieces, parts of it. I would advise if you're gonna do it for a project, do it together. So don't go there with 50 students asking for the same parts, because you have to cut it out. And it's a lot of work for them. So I would, yeah, you can download it absolutely in different ways. You have to choose the right settings for it.
Oh, this is nice. Downloads got trees, bridges and buildings, and they're all in
LOD2.
And you can download them as a drawing or SKP.
AutoCAD, DBG, SKP is SketchUp.
Oh, SketchUp model. Yeah, I think if you download a whole neighborhood like here, that people are not involved in it, you can do that automatically. But if you want to have a special area, then people have to make that for you. And in that case, it could be interesting to ask for as a group, ask for data as a group and not.
I think that's an experience from ON5 from your group, isn't it?
Yep. Yeah, where they're complaining to the university that too many students were asking questions, and if we couldn't make that into a nicer workflow for them.
Okay. Erik, I think it's nice to end the first quarter of this meeting.
Yeah.
So you have a couple of minutes coffee break, and then after the break, we will continue with QGIS and the data packages. We have shown you now a bit about the general 3D data in QGIS, the kind of sources you have, like the Bach 3D, and the BGT, but also how other information is on the internet. In the next quarters, Erik will elaborate on the geo packages, the BGT and the OSM, and how to clip or extract that kind of data.
Yep.
We will also explain more about layouts of the QGIS environment, of making layouts, improving the visibility of the data, you could say, filtering the data, although we have a bit filtering the actual versus verlopen, we did it already. And finally, we can jump into the Rhino again in the last part of this workshop.
Yep.
I suggest we have a couple of minutes break, and then we continue with the second part.
Yeah,
Erik, what time do you like the people to be back?
In 10 minutes or so. Let's
10
see.
minutes.
Now 38. Well, let's do 10 to 10. So 50.
10 to 10, 50.
Yep.
So a break till 50. It's nice. In the meantime, a lot of people joined as well.
Yep.
We will see you back in 10 minutes. Please be there on time, so you can follow everything from the beginning and you don't drop in halfway.
So, and if you have any QGIS questions or data questions, put them in the chat in the meantime if you want. And the more you ask, the more I can focus on the things that you're encountering. Otherwise, I'll just be telling what I think you might be interested in. But if you know more about it or you want to know more, put your questions in there, and I'll see that I'll answer them in the course of this morning.
Okay.
See you in 10
Thank
minutes.
you. See you in 10 minutes.
Should I break the recording session or keep it rolling? I think it's better to break it here.
Yeah, if you break it and then you will get it. I hope it works if you do it in different parts, that we get all parts separately then.
Let's stop share and let's see if I can. Oh, pause recording. Stop or pause? What is best?
Pause.
Pause.
Don't forget to start it again then.